5-7. Similarity and congruence. Yesterday was about congruent figures and your transformations. Today, you'll have the same thing, but you'll also have dilations with it. Pretty simple. Let's just make sure I don't need you guys to talk. Let's just make sure that you understand what we've been doing, all right? So, similarity. By now, everything should be fairly simple for you. Similarity transformations. Same shape. Different size. Congruence means they're the same size. Same size. But similarity means the size has changed. The shape is the same, but it's either increased or it's decreased. Remember doing that? Chapter 4?
Yeah.
And the transformation or the dilation that they used, they multiplied each coordinate by some number, right? So if the figure was getting smaller, then you multiplied by a fraction less than 1. If the figure is getting bigger, it was by a fraction bigger than 1, like 3/2 is 1.5. Or you can multiply by 2. The dilation is by multiplying by 2. That made the picture bigger. Multiplying by 1/2 made the picture half as big. Okay, so that's just a quick review of the dilation. Congruence, just to formally have it down. Congruence, transformations. Same shape and size. We already said that. Now today, what you're going to be doing is you actually have to give me the coordinates today. We're not going to be putting these on graphs. You can use graphs if you want, but you have to give me the coordinates today. And you have to tell me what transformation took place. Tell me if it's a dilation. You tell me if it's a translation, a reflection, or a rotation. Okay? But it comes down to understanding what you did yesterday. So, how can you tell a translation? So, what happens is, to x and y, what goes in that place? X and y, but what else? Yes, Ed?
Plus sign and minus.
Plus or minus, depending. Okay, so we'll just say, if you're shifting to the right, you're adding something, we'll say h, to be formal. And if you're going up, you're going to add something, so we'll just say k. So h and k, you're going to the right or you're going left, it would be negative. If you're going down, the y, the k would be negative. Does everybody understand that? So you're shifting left and right and up and down. So everybody understands translations based on yesterday's homework. But now you're going to be given the coordinates and you got to be able to tell what's happening. So really we need to rule out the other things. So let's talk about reflection. Okay? So if we reflect about the x-axis, do the x coordinates change? What changes? If you reflect the y. So this is what it looks like for a formal thing. Your x stays the same, but the y becomes its opposite. There's a couple back there. You want flat?
I just need 2, yeah. Just like 2.
There may be 2 back there.
He always has to interrupt our class.
Is there one back there?
There's block one and there's this.
You want both of those or you want a different one?
Give me another flower.
Yeah, tell me your choice.
Oh, we're gonna have a fight here.
Just take this. I mean, they go in there. It was packed full, but I keep losing them.
Gosh, Trippy.
All right. So if we do the y-axis, what is happening to x and y?
They be changed.
The X changes with the Y.
Yeah, the x changes to its opposite,
Oh, God.
and the y stays the same.
Wait, what do you mean the X changes to its opposite?
So if you flip around the y-axis, that means you're moving left or right, which is a change in your x value, right? Here, let me give you an example. So here, on this one, we're going to rotate, or excuse me, flip, reflect about the x-axis. 1, 1, 2. The coordinate, 1, 2. So if I reflect this about the x-axis, that means it's going to be flipped down, right? To here. So what's that coordinate? 1, -2. What changed? The y value changed. Alright, now if I flip about, or excuse me, reflect about the y-axis, this one, here's the y-axis, that means it moved to the left.
The X be changed.
So the x changed, and the y stayed the same. So that just means you change the sign. Everybody understand?
Yeah.
That's what you're supposed to have gotten from your homework. And that's what you're going to be doing today. You got to recognize those things today. Rotation. Okay, let's start with 90 degrees. And we'll say clockwise first. This is a little bit more difficult, but there is something that changes. So your x and your y
Both of them
change. And this is just something you have to figure out. Okay? You can use your notes for this. So y changes to its opposite. Oops. I'm sorry. Alright. Not for clockwise. The y moves into the x position. The x moves into the y position and becomes its opposite. Well, okay, watch. If we rotate this point 90 degrees, it's going to be down here somewhere, right? Alright, it's going to be down at 2, -1. Notice that the x and the y flipped, and the x became its opposite. So that's all this is saying. Got it? Good. Well, that's too bad. I'm going to have to think about it. Counterclockwise. This is what happens. So if I go 90 degrees to the left, this is going to be at -2, 1. What happened? They flipped. X and Y flipped, right?
Yeah.
And did they both become opposites? Did one change or
One
which ones?
The
The Y changed.
yeah.
Excuse me, in the X position. Right. The Y changed
And the X is
in the X position. It's called studying, and I have no sympathy for you if you're not getting it. Okay, 180 degrees. 180 degrees. We did talk about all of this yesterday. What happens to your X and your Y?
They become negative.
They're opposites,
yeah.
but they stay in the same position.
Don't talk like that.
So if I rotated this 180 degrees, it'd be 1, -2. -1, -2, sorry. Notice the X, they stayed in the same position, but they became the opposites. Okay? something that you should know. You should make sure you make note of that because you're only going to be given the coordinates today. You're not given the graphs. So you got to recognize this stuff. All right. Example 1. A is at 1, 1. B is at 1, 4.
What are you looking at?
And C is at 5, 1.
No, I wouldn't laugh.
So, I want to reflect this about the y-axis. So you take out your handy dandy notes. We're reflecting the y-axis. What happens? The x is in the y.
They straight it.
No, what? The x becomes negatives.
The x becomes balanced.
Yeah, if we're reflecting about the y-axis, the x changes, the y stays the same. So A prime is where?
Negative 1, 1.
There we go. B prime.
Negative 1, 4.
Negative 5, 1.
C prime?
Wrong.
Yep.
Yeah, he's smart.
Nope. Not unless it says graph. You don't graph unless it tells you to graph.
What if graphs help us?
So this was reflection y-axis for your notes. That wasn't so bad, was it?
No.
Okay, well let's try something else here. Let's rotate the same one 90 degrees, clockwise.
They switch position.
So, look at your notes. 90 degrees clockwise is this first one here. What happens first?
They go from being x and y to y and x.
And then change the x to its opposite.
Yeah.
So, A prime here is going to be what? Look at A. So you switch them, which they have to be the same, but then,
It is negative.
there you go. All right, Hannah, what is B prime?
1, -4.
Here's your x and your y. X now goes in the y position, y now goes in the x position. So you got to flip them. So it's going to be 4, 1, and then you
Oh, okay.
make this in its opposite. Mind your way over here. Sorry.
Oh,
Sarah, do you want to do this one? Was that a yes or no? Okay,
it would be 1, -5.
that's right. Switch your x and your y and change your y to its opposite.
What if it's already a negative? Is it?
Then you change it to positive. All you have to do is kind of follow this.
So on first y-axis, if A prime was like just A, right? Okay, so if you switch them and it's like you rotate it 90 degrees clockwise, would it be the negative turning to the positive?
This one right here?
Yeah.
Yeah, that's what she just said.
Yeah.
Yes.
So on 180, it doesn't matter if it's clockwise or counterclockwise, they both go to negative.
It'll be the exact same position.
Okay, just make,
You change the sign, yeah.
okay. So no matter.
No matter what. All right. So here's the thing. If you don't find this happening, this from here down, then you must have done a translation. Because this is not necessarily easy to see just looking at coordinates. These are a little bit easier to see, to recognize. All right, example 3. Tell me what happened. Oh, sorry. Example 2. Gosh. Tell me what happened. Here's A. B is this. C is this. prime is now this. Don't blurt it out once you figure it out.
Oh,
Just keep it to yourself.
I wasn't.
So here's an example of what you're going to do today. Tell me what happened. Raise your hand once you know. Rotation counterclockwise. How much? 90 degrees. Yeah.
I thought it was reflection across the y-axis.
Well, let's see what happened. Maybe I wrote it down. X and Y, they flipped.
Oh,
Okay. And then Y, what was it? 90 degrees counterclockwise does what? So,
Flips in the X,
The Y.
X and Y, yeah, okay. However you want to say it. All right, example 3, let's do this one.
there you go.
A is at 2, 4. B is at 3, 5. Do I really need to put all of these down?
No.
Yes.
You sure do, bud.
I do?
No.
No?
No, you only really need to look at one, don't you?
Yeah, why should you give it away?
Oh my gosh.
What?
What? Just the translation.
Stop saying what?
Pressure now.
You're multiplying by 2.
Wow. Oh,
Give it away.
Brianna?
Translation.
Nope.
I know it. Isn't it a dilation?
Yes. How much? Good.
Right.
By 2.
By 2. Multiplying by 2.
Yeah.
Dilation by 2. Okay, here's how you do this. You take this number divided by that one, and that's really what you're doing, what you're multiplying by. 4 divided by 2 is 2, and then check everything. Make sure it's all the same. 10 divided by 5 is 2. 12 divided by 6 is 2. So if you can't figure out anything else, check the dilation, because it's going to be a fraction, and it's not going to be something necessarily as easy as this one. It may be 3/2, but you have to take this divided by that and then check all of them to make sure that they come out to that fraction. If they do, then it's a dilation. Okay, if you did -2 divided by 1 is -2, but -2 times 2 is not 1. So this is not a dilation. See how I did that? -2 times 3 is not 2. -2 times 5 is not -1. Okay? Yeah.
Yeah.
All right, your assignment. Page 233, 1 to 20, 29 and 30.